Hello, good evening once more. So let us continue with this other question, the question 6, which says, let us consider an equation half mv squared equals mgh, where m is the mass of the body, v its velocity, g acceleration due to gravity, and h the height. Check whether this equation is dimensionally correct. Okay, let us start. We are having that half mv squared is equals to mgh, where m is that. So let us determine that the equation is dimensionally correct. So let us start by the left hand side, half mv squared. Let us say considering left hand side, something like that. Considering left hand side, half mv squared. So dimensions of left hand side is equals to dimensions of half, dimensions of m, and dimensions of v squared. And half is a constant, so the dimension can put 1. The dimensions of m, which is mass, is kilograms. The dimensions of mass is big M, and the dimensions of velocity is same as velocity. Remember, velocity is distance on time, so the dimensions of velocity is dimensions of distance on dimensions of time, and distance is length, which is L, and time is seconds, which is T. So dimensions of velocity will be dimensions of length per time, but remember we are squaring it here. So that is it. So that is the dimensions. So for the left hand side, I can say the dimensions of the 1 times that does not keep it, so L squared t to the negative 2. So that's our dimensions on the left hand side. So let us also check for the right hand side. So considering right hand side, which is mgh, the dimensions of right hand side equals to dimensions of m, dimensions of g, dimensions of h. Dimensions of m, let's forget to put this square bracket. Dimensions of m is ground m, and dimensions of g is acceleration. In all cases, acceleration is always change in velocity over time. Change in velocity over time is acceleration. So dimensions of velocity, we just had it update to be length per time, and this is dividing by another time, so we are having per another time, so we are having length per t squared. So that is the dimensions of time. I just added this one in, so indices t, since they are having the same base, I add the times -1 plus -1 gives -2. I use the number line. Okay, so that's it, and the dimensions for acceleration is now known. So all acceleration, no matter the acceleration, is it due to gravity or due to what, it is L t to the -2, and the dimensions for the height is always length L. So the dimensions for the right hand side will be m L squared t to the -2. So let us check, is it homodimensionally correct? Yes, this is the dimensions of the left hand side, and this is dimensions of the right hand side. So it says since conclusion, you conclude, since the dimensions of left hand side is equals to dimensions of right hand side, hence the equation is dimensionally correct. Dimensionally correct. Please don't make a mistake and say that the equation is correct. Say it is dimensionally correct as they ask you, as you were asked. Okay, that is that. Then they say that evaluate alpha and beta in the equation E equals to cm alpha, m to the alpha, v to the beta, where E is the kinetic energy, m is the mass, v is the velocity, and c is a dimensionless constant. So let me write it down. So they are saying that question 7, E is equals to C m to the alpha and v to the beta. So m is mass, E is energy, so dimensions of energy. We know dimensions of energy. What we are even working up here is energy, so kinetic energy, potential energy, the formulas up there. So we'll just use ml squared. So I will say dimensions of E is equals to L squared. Dimensions of E is m L squared t to the negative 2. Then dimensions of C is 1. It does not be dimensionless constant. That's what the question is saying. And we have dimensions of m to the alpha is mass. Dimensions of m is simply m, but in this case it is to the power alpha. Then we also have dimensions of v to the beta will be equals to dimensions of v all that to the beta, something like that. And dimensions of v, let's say v is velocity, so it will be L t to the negative 1, but all that to the beta. So a dimension, so in general we have dimensions on the right hand side. Dimensions on the right hand side is equals to having 1 for C and m to the alpha for B and L to the beta, all that. We remember that a b to the power n is a to the n b to the n indices, right? So I'll apply it here. So we'll be having m to the alpha, so we'll be having L to the beta and t to the negative beta, something like that. So which would have is equals to 1 times that is still the same thing, t alpha to the L to the beta, t to the negative beta. And this is these dimensions have to be equal to the one on the left hand side, which is m L squared t to the negative 2. M L squared t to the negative 2. From here we can start equating like terms, right? So you see that alpha have to be equal to the that is in indices. We will start equating that this have to be equal to the power of this. So alpha negative 2, so alpha have to be equals to 1, because the power of m here is 1. Then beta have to be equals to 2, the power of L is 2, and negative 2 have to be equals to negative beta, and beta have to also be equals to positive 2. So these are the values for alpha and beta. So alpha is 1, beta is 2, and that's all. So you can even use any of the two equations to determine the value for beta, either L or T. So that is it. So the equation for that equation to be homogeneous, alpha have to be 1 and beta have to be 2. As easy as that. Then let us move to the next question, which is saying that